All right, thanks everybody for joining today. This will be the last CIN talk that we have of the year. So naturally, I wanted to pull back a community member that was absent for a little bit, but he's still around, and he was kind enough to give us some time today to go over some work that he's been doing. He explicitly wanted me to say that this isn't an IPv6 talk, but I think that that's going to be the undercurrent here. But I'd like to welcome Jeffry Handal, who is going to be talking a little bit about evolving IP to solve problems. So I'll throw it over to you, Jeff.
All right, thank you for the invite. Appreciate it. Yes, I purposely avoided having the mention of IPv6 on anything in the abstract and the title. I learned that from Mr. Alan Winery, that if you do, people drop. So don't start dropping just yet. It might be a little bit practical and it might be a little bit fun. So there's going to be things that you're going to see that you may or may not agree with. That's okay. That's the whole purpose of the talk, is to get you thinking, agreeing or disagreeing. But the whole idea is I want to keep it practical. Now, as Jason mentioned, I used to be at LSU. I was very involved in the community, but I still remain involved only in the IPv6 working group. So Alan still lets me in. So I'm still pretty active there because IPv6 is it's not a fad. It's a passion, and I get to learn from all you guys. So here we go. So first of all, I am coming to you live from home. So I am in Houston, Texas, hence the hat today. And I didn't shower or comb my hair, so it's COVID time. So get used to it. So let's let's dive into it. So we're gonna look at a little bit of history for IP, but it's gonna be IPv6 only. Now, a lot of the timelines that you're going to start seeing throughout this presentation are not historically accurate. They're not meant to be. I just picked a few little things, a few little nuggets that I thought were important to me on my journey for IPv6 and where we are today. So we're going to use this as the underlying event. Of course, things that will stand out that are very easy are IPv6 Day, World Launch Day. The North America Summit that you see there, even though it's held for many years over and over and over again, the why 2015 kind of marked something very special, stood out for me, is because that's when we started talking about IPv6 only. And that'll become more relevant here in the next few slides. So taking a little look at it, my personal journey now. Well, in the 80s and 90s, I had no idea what the internet was. I came to LSU as a student in 1999. I still had no idea what the internet was. I've never seen a computer, didn't know how to type. So hence why, what is the internet for me? Then quickly, I became a student worker and got shown the internet, this big, huge ATM router with all these lights. I'm like, whoa, that's the internet. Little did I know how everything really worked. But fast forward 3-4 years, I implemented IPv6 campus-wide in 2005, 2006. Again, experimenting, my newness, no history with IPv4 that much, which allowed me to take a look at it and start experimenting. But at home, it wasn't the same thing. At home, I could not get IPv6. I had to do tunnel broker. Thanks for Hurricane Electric's tunnel broker service. I was able to run IPv6 at home for a long, long time, till around 2014, until I moved to Texas, where I got my first ISP that had dual stack, which was Comcast. And then ever since about 2018, I've been playing around with IPv6 only, and this journey started jointly with my friend Alan, where we started experimenting on NAT64. So, and that's why I started to look at how can IPv6 only help me solve problems, which is the meat of today's presentation, like viewing it from a different point of view. But before that, what is the reality that we live in, right? I'm loosely calling ISP starting adopting IPv6. Client OS is starting adopting it as well, pretty early on, but as we know, it was very broken if you were in the early days. Content provider started a few years later, and that's when things started really interesting with Google, YouTube, because now it was getting a little bit more practical to have IPv6. But yet, to the very far right, you see the enterprise, and I'm using that term loosely again, because that involves universities, businesses, governments, a lot of these agencies that haven't adopted it are just starting to, because they're getting motivations for different reasons. So keep all these timelines in mind. But again, on the reality of things, where we're starting from, Well, the clients now support V6. It's 2020. They've been on a long journey. ISPs finally, I won't say all of them, but I'm going to give them a green checkbox that, hey, for the most part, most ISPs, even the laggards that where I used to live in Louisiana now have IPv6, should be covered. And I'm going to give the internet in general, hey, we have a highway that we can go across the world and hit some service in IPv6. And as mentioned earlier, the laggards are the enterprise. So just imagine if you walked away from this talk and say, hey, let me start getting this up and running, what would happen? Well, expect this to happen. That's the beauty of IPv6. Once you turn it on, it just mostly works. And there's a lot of content and highways that you can get to. So, and that's a good analogy that I always like throwing and using over and over again, because it does feel like the floodgates. And if you look at historical graphs of IPv6, you will notice that once it turns on, there's always a spike, and then that spike remains. And that's why this reminds me of it. Also, in today's world, again, using all this context as our starting point, this year, 2020, marked a very important year because we hit over 100,000 routes in IPv6, which tells me more and more enterprises are starting to adopt it, which is why in that timeline that I showed earlier, I put IPv6 starting roughly around 2019, 2020, because we're starting to see the increase of adoption. Now, there is a report that the IETF sent out and probably circulated the IPv6 working group earlier this week or last week for different reasons why. There's a lot more incentives and things like that. So read that report when you can. If not, ask Alan for it. So let's look at how can IPv6 solve problems. So first of all, I like to look at IPv6 from a simplicity standpoint because it's very automatic. I don't need DHCP servers. I don't need a lot of the traditional things that we need for IPv4 don't need to be there. It just, you plug it in and it starts just chatting away. Now, security is a whole different ballgame. We're not going to talk about that today in such depth, but just remember, it is very automatic. It's multicast and a neighbor discovery protocol, all these things, all these protocols just simply work, start chatting and figuring things out for you. So it's very simple and automatic from the user standpoint and bringing it up. And I say no DHCP mostly because we know there's uses for it and stuff like that. And I'll get deeper into that one later on. I am of the notion that because we started IPv6 and we learned from IPv4, we're doing better summarization. To me as an engineer, it has the option to take up less memory in theory if you're doing it right. We've learned not to take small subnets or IP addresses because we can in IPv6, or we shouldn't. So the summarization routes for different ISPs should be a lot more improved, which is why I know one of those efficiency things that I'm calling out. So again, it's all depends on how you configure, but in theory, it should be a lot more summarized, a lot more efficient, because I could just say /3 and I just covered everything. But we know we're not going to do that, but it is possible. One of the biggest things from a solving problems perspective, every time you solve a problem, you do it for a reason, not only technical, but also cost-wise. We all have budgets. We all report to somebody that a project will not happen without money. Well, look at how much acquiring IPv4 costs today. In today's market, we're looking at roughly $25 per IP address. And give or take different marketplaces that are out there, there's even a black market for it. Some of you may know of people that are trying to sell their campuses IP addresses for a profit. Who knows? But the idea is it does cost money. It's not free. And like I said, there's marketplaces out there, and these are the latest numbers I saw recently from the marketplace as early as this week. So, and again, this is an approximation. So when we're trying to solve a problem, we always associate solving a problem with a cost. And if the cost is going to be higher because of IPv4, IPv6 could be the perfect solution to help bring your cost down and get the project done. That's my argument there. Also, in terms of cost, having all these big boxes for NAT, CGN, they do cost money. And even some providers, and I'm referencing an article there, are charging for that extra cost because they're having to maintain extra gear. I'm going to call it legacy gear to be able to maintain IPv4. So all these are incremental costs that increase complexity and make your project a little bit more expensive. So IPv6 to the rescue here to bring down costs. The other thing too, again, in this whole notion of solving problems is this idea of automation. I kind of alluded to it earlier, but when we look at it from an ISP, and I know a lot of the people on this call tend to run big campuses or research networks, I usually view those as you're kind of an ISP because you're providing connectivity at scale, vast geographies, and sometimes it's really hard when you have to do it one at a time. You need to be able to figure out how to scale it, how to be very programmatic about it, and best of all, you need to allow it to self-heal, because many times we're doing it with 2-3 staff to support 100,000 users. I mean, that's insane, but it's normal in this space. So again, I view IPv6 as that glue to make a lot of this possible because it scales, it's programmatic, it's very automatic in nature. And again, it's one of those key concepts I want you to take away. Automation equals IPv6. Also, many of us in our campus or the researchers that we support tend to focus on this new industry revolution, which is a lot of buzzwords around this. What does it mean? It means more sensors, smart cities, cloud computing, all these things that we have done research or are doing research actively on today. However, one thing that they all miss is that it needs to have pervasive connectivity. We know IPv4 cannot deliver that, which means IPv6 is a natural fit to make a lot of these things reality. So when you're working with your researchers and they're in any one of these arenas or these research areas, remind them they can't be thinking about things in terms of IPv4. Their solution is going to fail. It's not going to scale. They have to go to IPv6, and might as well get them from the get-go down the right path than have to get to the end of the research and be like, oh, we're hitting a roadblock when we actually try to implement it. And let's try to save them some money and some time as well. Also, one of my favorite things about IPv6 is how creative you can be. Now, the first address, I'm not going to confirm or deny, but I tend to use those addresses a lot in my network to tell me that I am actually on my segment. And I like to spell out the word Cisco because I do work for Cisco, but it makes my packet captures a lot cleaner. I don't have to look at all these random characters. When I start seeing the word Cisco and then the VLAN number, which is right next to it, it stands out. It makes troubleshooting a lot quicker. It's a little bit harder to do that with IPv4. And Facebook has been doing the same thing for quite some time. And some of our friends, some of you may be familiar with the little project that I am alluding to there, the IPv6 board, because it's again from one of our retired colleagues that's still pretty active, Mr. Craig Miller, out in the marketplace. But so he's been doing some fun stuff with this too. And then the notion of creativity, again, if you've seen the jingle, I'm going to call it the Jingle Bell Christmas tree, it's coming back this year. I actually checked it in last night to see if he had it up. The video feed was still not working, but he did. The person that did create it in Europe is bringing back the Christmas tree. So if you ping it, it'll light up different LEDs on the tree itself, and you can nerd out. And then Mr. Eric Vink, who's an IETF person and also works for Cisco. If you go to his website, based on what address you're coming from, it'll create a little color pattern from your IPv6 address. The idea being IPv6 allows you to be creative. A lot more than what IPv4 ever did. So those are just teasers of how I like to think about IPv6 in terms of solving problems. But I'm going to get to the more thought-provoking portion of the presentation and how we use IPv6 to solve problems. So again, and this is the portion that you may or may not agree with me, but that's okay. And the idea is to get you thinking about it. So first topic, there is a need for speed in everything that we do. We've seen talk about 5G, even 6G. I've seen talks about 6G starting actually in the last 2 weeks. online gaming, a lot of us are probably gamers, and we know when things are slow, they suck, and we cannot play online, especially if you bought into Microsoft Flight Simulator, you want it to be smooth. We have a new type of ISP coming online, which is Starlink. And then we have augmented reality. But all these disparate things that we see here, they do have one thing in common. It's not about speed necessarily. They're trying to get rid of one common denominator, one common problem that they all have, which is they're trying to eliminate latency. So you might be wondering, what the hell does latency have to do with IPv6? Well, I'm going to get to that in a second. But the idea is all these disparate, cool new technologies that we're after, we can't keep giving them more bandwidth. I mean, we can. I mean, that's why we have 400 gig specs, maybe 800 gigs in the near future. But that still doesn't eliminate latency. Latency is still going to exist because there's a thing called the speed of light. And funny enough, I've had to explain to a physicist why he could not instantaneously move data from the US to Japan, because there was a little thing called the speed of light. He could not comprehend that, even though he was a physicist. I'm not going to mention names or where this was, but I could not get this concept across this person. So we have this speed limit, right? Well, with that speed limit also comes this thing called latency. And as you guys know, we cannot operate at the speed of light. We're trying to with different experiments and CERNs and stuff like that. But in the meantime, while we get to that speed limit, we have to contend and deal with the technology that we have today. So we've done a few tricks. We've created CDNs. We've created anycast addresses. We've added big pipes. And again, the whole idea is not to necessarily get there, not to give you more bandwidth, but it's actually to get there faster, reduce that latency. Latency is the underlying enemy. And by having things closer to you is how we've been able to mitigate some of this latency. But at the end of the day, why the hell do we want all this latency to be eliminated? Well, the answer is very simple. And I took this from the IEEE Spectrum magazine. Some of you may be familiar with it from the IEEE. One of the things that they were talking about is how do we get rid of latency to be able to enable these new applications that we're after. So we've learned how to live with voice over IP and video chat like the one that we're on, but because of how our brains work, 150 millisecond latency is okay. It's doable. We can live with it. The fact that my hand is moving, my voice is moving, and it's getting to you 150 milliseconds or less later, still works because our brains are not that fast yet. However, as we go into applications like multiplayer gaming, virtual reality, autonomous vehicles, which we keep hearing about all over the place, and I mentioned 6G networks, I've started to see talks about that. Look at the latency requirements that they're going to start looking at. I mean, we're talking about 1 millisecond latency for some of the applications in the future. Of course, we're looking at maybe 10, 20, 30 years in the future, but we got to start somewhere. And to deliver this type of reality and network, we have to do something about it. Well, one of those things, and this is probably the controversial part I'm proposing, is IPv6, not as the only answer, but one of the answers to get us to that reality. The reason why I view IPv6 transport as a contributor to get us closer to all those realities and reducing latency is because, of course, we get rid of NAT. If we have one less thing looking at a packet and manipulating its header, that adds up, especially if you're talking about NAT at home or at the enterprise. CGN if you had it upstream, and all these boxes or middle boxes that are looking at those headers, and even though they're doing it really fast, I mean, technology has evolved a lot, it's still all those tiny milliseconds do add up. If we avoid that little process, we're going to help contribute to getting to those latencies that we require for the future. Second, notice the difference between IPv4 and IPv6. IPv4, a lot of the headers and checksums are actually being done on the routers themselves. With IPv6, we moved that to the end host. So a lot of the middle boxes, all these routers, all these things that are going to interconnect everything, don't have to do that checksum processing in theory, which means a few more milliseconds are being saved. We're not letting the end host kind of deal with that. And we're just helping it get there as fast as possible. The other part is, I mentioned it earlier, is better summarization. If we have all these routers that are still interconnecting the world, we want them to make their lookups as quickly as possible. Any millisecond you can shave off there because we have the potential of better summarization, then have at it. And it all adds up. Again, IPv6 transport is not the entire answer. It's going to be a contributing factor to getting to those 1 millisecond latencies in the future, at least in my opinion. Now, let's take a step back. What is actually going on today? We've seen that there is a lot of research papers. We've seen it on NANOG, IETF, that, hey, IPv6 is always faster. But there's always and ifs or buts. And the reality is there's always going to be until we get to a uniform state for IPv6 across the board. So the test I'm showing here is actually from my home yesterday. It's a 50 meg connection over AT&T, as you can tell. Even though IPv4 was faster from a pure bandwidth perspective, in terms of compared to IPv6, no idea why I didn't research further. My point was looking at the latency. One of the cool things about fast.com for testing is that they do 2 types of latency measurements, which I really enjoy. And notice IPv4 when it's unloaded, and according to our definition, unloaded means I'm starting everything from scratch. I don't have anything pre-built. It takes a lot longer compared to IPv6. Now, still don't have the answer why. There's probably a myriad of things that's for further research for me to do. But notice how different they are. Despite the bandwidth being much higher for V4, the unloaded latency is orders of magnitude very different. Now, when they're both loaded, they're functioning sort of similar. It's probably variations depending on the path I'm taking, optimizations that haven't happened for V6, at least in the segment I'm on. But it's very curious to look at this, not from a bandwidth perspective, but from a latency perspective. I'd be curious to see what you guys get in your own little tests from your own networks that have IPv6. And again, my tests were IPv6 only networks versus IPv4, not dual stack. I purposely avoided having dual stack because that adds more complications to the testing, just for fun. Now, moving on to the next section, I'm gonna, in the spirit, whether good or bad, of COVID, I'm gonna be calling this section the IP contact tracing. And again, you guys already know we're gonna be talking about IPv6. So let's look at why we wanna trace IP addresses. So in the past, we've always been worried about, we have to know which user has which IP address all the time. In a V4 world, yeah, that was doable. In a V6 world, with privacy addressing and differences in different OSs, we know that's becoming really hard. So, but there's a lot of reasons why you want to trace an address to a user, right? You get DMCA complaints. Maybe FBI is looking for somebody, they did something they're not supposed to. Regulation somewhere in the world, or legal requirement, or because we've always done it. Tradition sometimes is probably the hardest thing to get rid of, but it's one of the things that we always do because we've always done it that way. So keeping all these things in mind, when we're transitioning from V4 to V6, we have still that same mentality. We still want to create some kind of tracking mechanism, but we already know that in the V6 world, we're going to run into issues. And a lot of these things will not be a surprise to a lot of you guys because you've probably been dealing with it or trying to tackle it. Well, tracking and privacy are at odds with each other. So I know a lot of us love our privacy, but at the same time, we're network admins. We need to be able to figure out who's got what when for all the reasons that we stated before. But they're not going to play nice with each other. We're starting to notice, especially with the latest Apple iOS, MAC address reliability started to go away. And that's one of the things that's always been constant for us. The constant across V4, V6 has typically been the MAC address. Well, that's going away. I'm sorry if you haven't seen that. It's the reality that we're going into, which makes tracking a lot harder too, because we don't have that common factor. Second, or third, we need bigger storage, and that costs money. We can do a lot of tricks to be able to track with V6 despite the privacy addressing, despite all this automation that happens behind the scene and no reliance on DHCP. There are tricks to be able to scrape your routers, get this data, but it's not going to be sustainable as more and more devices go V6 only, or just V6 on, and even if it's dual stack, your storage needs are going to grow, and that's not going to be sustainable. We have to figure out what we need to do. And of course, depending on which OSs come to your different campuses or networks, how you tackle this problem is very different. It's not uniform. I'm just going to mention it. Android and Apple, for example, we all know the issues we have with Android, for example, no DHCP v6, stuff like that, and which I mentioned. So all this needs to, this is the part that I'm going to introduce a little controversy. So we still have, I'm not eliminating that we need to track people. That's going to be always a need for some reason, but we need to change the way we think about tracing. What if we track things based on the identity of a network? Does that supply us with enough information with all our regulations and all the things that we need? I don't know. And I'm going to do a little demo about what this potentially looks like. I don't have an answer for this specific one, but I'm thinking about it in terms of IPv6 to identity mapping somehow. Do we rely on username? We've done it on wireless. 802.1x has been there with us for a long time. We know we can always tie username to one IPv6 address, 2 or 3, and that's historically worked. But where we've missed the mark is, how do we do the same thing on the wired network? So we've done it on the wireless, but we haven't done it on the wired because it's difficult. But maybe do we have enough of a motivation to do it now to track them? And I'm also open to ideas. I think at the end of the presentation, we probably have a section for Q&A. I'd love to see what else you would throw at this section, because this is probably one of the ones that we still need to figure out. How do we do it best? Do we embed maybe an identity in somebody's IPv6 address, so no matter where you go, that identity follows you around? Do we do it by network, by username? Do we make it ubiquitous that we have all a universal ID no matter where in the internet we go? But then that gets into the whole space on privacy, because we can probably predict that Jeff always uses Cisco in his IPv6 address, or things like that. Just food for thought. And if you are very, very curious and want to have a say and not just discuss it in a verbal exercise with me, the IETF actually formed a group called the Mendinas Group that is looking at this problem of tracking and traceability, with MAC addresses just being randomized now and changing. How do we solve this problem of tracing and tackling it? So look it up. It's just getting started. It's not an official working group just yet, which means it's at the very early stages, but the conversation is getting really, really interesting there. So with that, let me jump on the little demo of what I'd like to do here. So let me switch to sharing. Let me share my desktop now. And here we go. So as an example, I'm just going to use the Cisco Meraki platform just for show and tell, just to show you how I'm thinking about things. And let me log back in. I timed out. And awesome. So I mentioned there are ways to do a lot of tracking, but is that tracking sustainable? Are we only looking at a glimpse of a period of time? So this is actually my network, which is IPv6 only. I have segments that are IPv6 only, dual stack, and NAT64. And you see, we can definitely track an IP address, great, but what happens if that IP address changes, right? We need to scrape it for different periods of time, what it used, and things like that. So let me scroll down and take a look at just my wireless clients, just for right now. Look at a laptop. And let's see. So a few things I mentioned, we can track it to a user. We can track and create all this extra storage to track all the addresses that the device has ever used. And you can see right here, I am tracking all those addresses. Even my linked locals have changed over time for some reason, but we're tracking it. But at some point, this is just going to be not sustainable. I'm going to have to have a time limit. After 6 months, I won't know what happened, or 3 months, or whatever the magic number is. We're still experimenting with how much storage we're going to need and how useful this can be. But you start to see that, hey, maybe this is not such a great way to track a user to a device. Maybe we actually do use the user. We embed information inside the address, things like that. So there are different techniques that you can use. Now I'm going to switch over to another platform where I've been messing around with a thing called identity in the network. And I'm going to have to load this again. It timed out for me. Apologize. So I'm going to use Mr. Alan Winery's server. I'm assuming it's still up. And what I'm going to do is what I mentioned. I'm going to contact trace what has been connecting to IPv6 Hawaii.org, just for fun for right now. Essentially, what I'm going to be doing is I'm looking at things from the network standpoint, which again is not probably the answer, but it's an answer of where something or someone connected to IPv6 Hawaii.org for some reason, and why did they do it? When did they do it? So essentially what this is showing me is 3 different network identities, and I'm using some DNS tricks to be able to figure this out on how and when somebody connected. So this guy connected via IPv4, not so much fun. Oh, look at this guy. This laptop actually connected to it with 3 different IP addresses. And I just traced who it was, when it was, and sorry I've been hitting your server a lot in the last 12 hours, Alan. I just want to have some data. But this shows you how much in 12 hits my address has changed 3 times. But I'm not tracking it based on IP address. I'm tracking it based on network identity. And again, it's just an experiment. Does this make sense? Maybe not, but I'm still just doing some contact tracing on what's hitting an address. Now, the reason I use the word contact tracing is because, of course, if this is something, if IPv6 Hawaii were something malicious and I downloaded something that was bad or a file, I would potentially be able to see it. I'll be able to see it from where, who, what, and which addresses they use, which is the cool part. Now, Alan didn't have any bad stuff, so it's clean, so it's not as much fun. And again, another hit that I had from another address that I control. So I do have Comcast and AT&T at home, so I was trying from both. So I just essentially did contact tracing to IPv6Hawaii.org just for fun. And again, the point being is I'm using my location and my network as identity to figure out where and somebody or when somebody hit something. Hopefully this is making sense to you guys. The other thing I was going to show you guys is I also did, of course, test IPv6.com. A lot of addresses are hitting that server. And I probably, if I keep hitting it, I'll probably see a lot more addresses by the end of the day. Again, the point being is the network a way to create an identity, or is IP addresses? Maybe IP addresses are no longer the way to contact trace anymore. Maybe we do it by network, maybe by username. I'm more inclined by network and user combination, just because the list of addresses that a single device or multiple devices on the network might be able to see will just keep growing and growing and growing. And they might not provide value because we might not ever see that IP address again. So just food for thought. So with that, I want to jump back into the presentation and get us towards the end and open it up for questions. So hold on for a second while I swap screens here. So essentially what I want to leave you with is treat IPv6 as a way to solve your problems. So IPv6 as a solution is what I want to call it from now on. But IPv6 only, not dual stack, not IPv4, just IPv6 only, whether that's with NAT64, DS Lite, whatever flavor, but make it IPv6 only. How can IPv6 only help solve problems in your current environments today? Have you ever thought about it that way? How can IPv6 help? If you'd be surprised that if you do think about it, that it may help you solve problems. But because I mean, I've been at it almost 20 years now with IPv6, I have learned a few things. So it's not just me just saying, hey, just run IPv6 and call it a day. There are a few truths that you have to keep in mind. Well, first of all, IPv4 and IPv6 are not compatible. Even when we do dual stack, it might seem that they are, but they are not. They're very independent. They're orthogonal to each other. So remember that. Well, to be able to transition to IPv6 only, you have to deploy IPv6. I mean, that's something that people forget. And then once you deploy IPv6 only, then you can retire IPv4. And that's the best way to go about it. If you try to do IPv6 only from the scratch, you will get you will run into a few issues. But if you do it in that order, IPv6 only, slowly to retire IPv4, I think that's the best approach based on my experience. I've done it in many campuses, many businesses, and I've tried to do IPv6 only without even without even thinking about before, but it has failed because of different devices that can't connect and not providing a solution for those devices for some reason. So keep that in mind. And then as we get to the end, deploy IPv6. You'll hear me repeat it over and over again. It will help you solve problems, and it will open up the entire internet for you and your users. And next time I run into any one of you guys, I don't want you to be like Baby Yoda, that you still need IPv4. Make sure we're talking on the same page, IPv6 only, please. With that, Jason, I'd like to open the floor in the last remaining 15 minutes or 10 minutes for questions, discussion.
All right, well, thank you for going over all that detail. So what I'm going to do is, let's see. All right, if anybody does have any questions that they want to ask, certainly either use the chat room, or I think I enabled your ability to unmute mics since we're a reasonably small group today. In particular, if Alan wants to chime in with any sage advice or nasty words, you know, whatever he's feeling like today. He did point out in the chat room that there is an IPv6 working group box folder that has presentations. And then also he pointed out that IPv6hawaii.org actually points to a device that lives at University of Hawaii. So I guess that works too.
Thank you, Alan.
So I did have a
small group is that the reason it's a small group is that you said IPv6 in the description.
there you go. I just scared them all away.
It was Jason. They dropped all at the beginning.
So I did have a couple of things that I chatted, or I wrote down here as you were kind of going through this. I guess from a home networking perspective, do you find that your life is made simple with managing it the way that you're doing, and has your move to Houston improved your situation versus what you had in Louisiana?
Yes, it did, because so moving to Houston helped, because that's when I found a provider that provided me native IPv6. It was dual stack, but it was native. I didn't have to do a tunnel broker anymore. So that was welcome news. Now running v6 only at home has helped because now instead of just having VLANs and IP addresses, IPv4 associated with those VLANs, now the IPv6 address can tell me which network I'm on without even having to go look up my different tables and figure out, okay, where am I? The address just tells me. And it makes my life troubleshooting much easier, especially when you have a lab with a lot of stuff in it like this. You need to be able to segment a lot of stuff properly and keep an eye on it. And having the v6 vanity addresses has actually made my life easier and spending time troubleshooting, connecting stuff in the right place.
There's a question.
So at least yep. Ben wants to know, what would you say to people who are in this situation? Quote, we're understaffed. I don't care about performance, and IPv4 works fine. And this would just add more work. Why should I care?
Well, I'm gonna take it from the grants perspective. So if you're understaffed, remember there's a lot of grants out there that you can use, and those grants do allow you to staff people. And one of the requirements for a lot of those grants is that you run IPv6. So now IPv6 just helped you hire one more person that will help you not only with your day-to-day operations that you have now, but also implement IPv6. Just a thought there. Now, if you're fine where you're at, you're not going to be able to join the rest of us and have access to the entire internet is what I tell people. Because there are things that you cannot get to that are IPv6 only, like the Christmas jingle bells, which is not practical, but there's other hidden nuggets that are practical out there.
Sometimes there's nothing you can say because it's a reticent, convenient position that they're making up so they don't have to be told what to do often. The world is going to move on without them. And, everybody gets at some point into the position where they're trying to win that argument, but it's kind of like climate change denial. What are you going to say? They're committed to what they're committed to. So.
Yep. Dave is pointing out that in the federal government space, everybody is supposed to get to about 80% V6 only by 2025. And there's a link there. And yeah, I know at the recent NOAA meeting, it was a big discussion. We've had lots of discussions within the DOE context on that as well. So there are some pushes from above to get there, closer now than ever before.
DoD DISA just made a big announcement about how they're going to take up IPv6 again. So.
Okay, well, I guess I'll throw out sort of a poll of the audience question to get people either talking or typing in the chat room. Since we're all spending time at home, more time at home than we ever have before, I have a dual stack IPv setup here from my provider since I'm on Comcast as well. And I don't have as sophisticated as monitoring setup as Jeffrey pointed, although that is some pretty cool stuff that you're using. Just looking at my Pi hole right now, looks like I'm getting about, 40% of my DNS queries are showing as being V6. So I'm assuming that probably roughly translates to about 40% of my traffic is V6. Anybody seeing numbers that are higher or lower than that? I was actually quite surprised, but I guess I really shouldn't be since I'm using mostly video conferencing services and mail and things that are probably hosted on cloud providers that are just doing V6.
Right. Content distribution and a lot of cloud is doing V6, but before the great pandemic, I have a slide that I reuse again and again. I probably used it when I talked in August, is showing 50 to 60% of traffic on our campus wireless using V6. And most of that's because a great proportion of the traffic is to and from the Google sphere, including YouTube, and what you just said. I want to point out to those that are uninitiated that Jason's Pi hole is a Raspberry Pi thing, nothing to do with his eating habits.
Thanks for the clarification on that.
Yep. So Ben, who asked a question earlier about if they're happy with V4, he provided more context. He's in K through 12. So Ben, in the future, K through 12 E-rate funding might have to start including V6 as a requirement, not just yet. So might as well get ahead of it while you can. But I haven't heard anything yet, but I have seen some school districts that I work with in some parts of the US that are asking for V6 because they're starting to hear chatter that may be a requirement in the future.
Thanks, that's a really good thought. We'll keep an eye on that.
Yeah, Ben, this is Celeste. I think one of the key things is eventually you and your staff are going to have to deal with this. And the longer you wait, the more burdensome it will be. And so starting to create a plan and at least investigating it and taking some training is not a bad idea. And the other thing is convincing people in the management that it should be a priority that you do this, and maybe even hire some extra staff to do the transition.
And here's the other approach, Ben, from a practical standpoint. If I were to ever go to one of your K-12 schools and I sit down on your network, get connectivity, and just start spewing out RAs, I just brought your whole network to its knees with little effort, just because you're not running V6. So food for thought there. At least from a security perspective, you're leaving yourself vulnerable. And kids nowadays, they're getting pretty smart about using computers. So they might be doing it on purpose or by accident. So,
Oh yeah, we see that. For more context, I'm at a provider that mostly serves K-12. So the question was more about, okay, how do I more ideas about how to entice our member organizations that are, reluctant or just don't.
Oh, if you're the provider,
motivation.
easy. Charge them
Yeah, we'll
more.
just turn it on for you.
Charge them more for V4, make V6 a little cheaper. That's what they do in China.
Yeah, good point.
I'm trying to get Celeste to do the same thing in California, but not yet. Or she retired.
I retired. I now work with the Internet Exchange, and we've had V6 from day one. So there you go.
Yeah. Timothy's indicating he only has a /64. He probably has AT&T because the PD, the implementation of AT&T is a pain in the butt, if I had to guess.
Actually, MediaCom. And early on, I actually had to craft RAs to keep my link alive. Otherwise, it would just fall over. So they had some poor implementation early on.
Implementation than like AT&T.
Yep. It's been stable though for the last about year and a half, 2 years.
Cool.
And I've finally got a stable PD. It was rotating like every half day when I was doing it. So.
Oh yeah, is Mr. Craig Miller on the line? He's been trying to get some service providers to be more stable with the prefix. But again, that depends on the implementation on the provider.
And then here's a good question in the chat room. Your opinions collectively. Do you think other countries, especially the poorer ones, will be assimilated in an IPv6 only world?
So Celeste already indicated that some already are. My experience in working overseas is some will have no choice. They're just going to have, they already have no choice right now. They just they get what it is, or they pay a lot more in the IPv4 marketplace. So which one's cheaper? Probably V6 only, and that's already happening.
The other thing to note in the international realm is if they're starting from scratch or building a new network, they might as well start IPv6 to begin with. So you may find out that many of the other countries go right to V6.
Yep.
So
similar thing has happened, especially in third world countries, when we went from having, let's say, copper in the ground, and then all of a sudden they skipped a lot of generations of technology and they went straight to cell phone towers. So you went from having just 2-pair copper to 4G speeds overnight, and that's what typically happens in third world countries like where I'm from. So I'm envisioning the V6 will take the same approach. And once they turn it on, it'll just be like the floodgates just open. Everything's going to work in theory.
It's a question you have to ask at every greenfield / forklift opportunity. In the Pacific, there are all these nations that have been VSAT based. They've been satellite provider based, but now fiber is landing on their shores, and they're actually building a brand new network. They're having a brand new path to the world. And at that juncture, if you just say, well, we're just going to commit to V6 only, it's a good time to insert it, I think. So don't let me talk too much. Mute me.
No, it's okay, Alan. You're a celebrity. Actually, I thought the meeting was till 1:45, so we have 10 more minutes.
Yeah, we get about 10 more minutes. I see our good friend Hervey Allen is on, and he has a lot of experience in the third world and emerging internet country space. So Hervey, any comments you can throw in on this?
Yeah, but Hervey doesn't like IPv6.
No, you're thinking of other members of our team, I think. I'm ambivalent. I like whatever is there. So my only comment, Alan kind of summed it up. So it's kind of, we've gone from transition of all these VSATs into fiber. The big issue is areas where obtaining IPv4 now is getting really hard. And so people who actually might not have thought about V6 suddenly realize it's there and they're interested. One example is there's been a long-standing attempt to get the Myanmar R&E network up and running, and they're discussing going IPv6 only from the get-go, which I guess would go against your advice, Jeffrey, right? For building from scratch. But it's been interesting to see. It really hasn't gotten off the ground yet in any serious manner, but it could be the first one to start up from scratch and do V6 only.
Well, internet, well, my advice was for developed countries. I should probably caveat that.
Yeah.
Right.
I think that-
AP-NIC is their RIR, so they have to deal with that fact as well in terms of needing
Hervey's point about obtaining V4, I think that's for Ben's question. That's the window, is when they're faced with buying a block of V4 addresses or jumping through some other, flaming hoops to get V4 addresses. That's the time that you go to them and you go, you could sidestep a lot of this by doing V6 only at this point.
Correct. And that actually has been some of the messaging we've given in a few cases. It's just kind of beginning to happen.
All right, well, I'll throw out a comment again. If anybody does have any other questions, either ask them or pump them into chat. Bruce is pointing out, okay, I hadn't clicked on that link yet for the, which one was that? The color one? Yeah, it's the color one.
No, he's I'm going to share my
It's Eric Vinke's page, which is a staple of IPv6 presentation, worth a browse.
So pretty much US adoption is increasing is what it's showing.
Although it seems to actually have taken a little bit of a nosedive during the pandemic.
That's probably because people started going back to the office. At home, everybody has V6. At the enterprise, they don't. That's my theory.
Yeah, good. Yeah, I'll buy that. All right. Well, it sounds like we may be at an end here. So thanks for the presentation, Jeffrey, and the good conversation. I think this is a perfect way to end out this year's CING talks. So everybody who's still on, we're going to pick up again on, I want to say January 8th. And I believe I lured Brian Tierney out of retirement to give us a talk on BBR. Yes, January 8th. So that's when we'll pick up this series again. So hopefully everybody has a good rest of the year, and we will talk to everybody in 2021. And I'll make sure that this video and the slides get posted.
Thanks, Jason.
We'll talk to everybody soon.
Thank you much.